Hey everyone, welcome back to Data Speaks. In this part 2 video of building an agentic AI chatbot with Hugging Face and incorporating web search, we are going to dive even further down after in the part 1 video we have completed installing necessary libraries and modules as necessary into the virtual environment, and then we have also imported all of those libraries necessary. Then we have checked our GPU or CPU availability. Then we have selected the Tiny Llama model because of the advantage of smaller model but yet powerful enough. Then we have set up our chatbot pipeline while integrating what task we want to solve, what is the model ID, then data type based on CPU and GPU availability, device mapping, and cleanup tokenization. After that, we want to continue here testing the model without the web search. We have initialized the model. Let's see if we can accomplish the quality output from the model without even incorporating the web search. So let's define a simple prompt that says you are a helpful AI assistant. This is a persona we are setting up. Then we are asking the question, explain me the self-attention mechanism in the simpler term. We are setting up response variable, what type of response we want from the model. That begins with a chatbot that we have initialized just above right here, the pipeline that we have initialized. We will provide the simple prompt, that's a question. Then max new token, how many the tokens we want from the model's output. So you can define the longer number of tokens if you like to, but here this is just a testing and we want to see what is going to be the quality of the output. The longer the number of token, it might be slightly costly here if you are paying for the model training. However, we are using the free version, so we don't have to worry about that. Setting up the temperature. This determines how much of the randomness and how much of the creativity you want to set up into the response of your model. So this way, we can define how specific answer we want. The larger size that goes about close to 1 and close to 0 is going to be very specific answer we want from the chatbot. So this is the hyperparameter. You can set up anything you want between 0 and 1. So 1 is going to be highly creative and a lot of context added on it, and 0 is going to be very specific answer. Then do sample equals true. We want to enable sampling on those responses so that it doesn't every time pick the most likely next token. Then we want to also disable or make it false on return full text so that we're only getting the generated part of the text, not the original prompt. So this is the response variable we are defining here, and now we want to return or get the very first response of out of all the responses generated by the model, and we want only the part of the response which is going to be the generated text. So this way you could configure your model's output in the way you want. Also, you could modify this question. If you want to test the edge case or the capability of the model, just explain more here and see what response the model is going to give. So let's run this and let's see what is going to be the output of the model. So look at this here. We have got the very first response of our model. It has given us the output. Let's quickly skim through this. It has explained about the transformers in the field of natural language processing. Then it has given some introduction about the self-attention mechanism or self-attention. It says it's a key component in the transformer architecture, which is absolutely true. It works by computing attention score between each token in the input sequence and also each token in the output sequence. Bunch of those looks like to be very accurate response. However, sometimes it might not be super complete because we have defined the max new token to be 150. If you are curious how long and how big response it can generate, you can always increase that or decrease it and see what response is going to be. Experiments always helps you to learn better. So you can try with any different hyperparameters and see what response is going to be. And do not forget to put something in comment so that I can also see what you have got while changing the temperature, while changing the max new tokens, etc. So this is going to be very exciting to know from you, and thank you for doing that. So next is going to be adding the web search. Here, as part of the next step, now we have got the basic response from our chatbot. How about adding the more complexity and getting more research specific answers or from the online resources? For the web search, we are going to use DuckDuckGo Search engine because that does not require any API key or neither the cloud account nor any billing setup. Unlike Google Search or Bing Search or Brave Search API, they are not for free. So they will charge some money to you. However, DuckDuckGo Search is our rescue. We can always use that and see what response we are getting from the search result. So we will define the function. We'll say web search as a function name. Then we will pass on the query. That's going to be our question. What question we want to ask. That's going to be the string data type. Then max result default value we want to set up to be 5. That's an integer type. The max number of search result. That's what we are talking about here. So 5 is the default value. And you can get anything you want, maybe 3, 5, 7, 10, whichever number you like to, but that's just a default parameter value we're setting. And as a return, we want to get the list of the dictionaries items that has several return components. I'm going to explain that in a moment. So that being said, we will initialize the empty list for the results because we want to store that many number of results from our model. Then we will create a context for the DuckDuckGo search, and there we are calling a variable search results. So here on the search result, we will store the result we have got from the DuckDuckGo search. So here query the question we want to ask and maximum number of result that we want to get from the DuckDuckGo search. You can change the number if you like to, but we are defining that to be by default 5 here if no other number was passed while calling the function. Then we want to run a for loop. We'll say for each result in search results, we want to append the result list that we have initialized just right here with the title and the title value, the key href. We want to get the link or URL, and then we want to also get the body with the key being body and then the value being the actual body of the search result or the output value. Then we want to add each of those values into our empty list we have initialized here, and we want to get that list as a return that contains the dictionaries of each output that contains title, href, and the body. That's going to be our result from the function we want to call as a web search. So let's execute that code. Then we want to test the web search function if it is working or not. So we will pass on a relevant question or similar question that we have asked to our large language model to compare how does the response look like. Then we will call the function we have just defined, the web search, and we will pass on the test query. This is the question we want to ask to the DuckDuckGo search. And then we want to get the 5 results as the search results. Then we will loop through all those results from the web search function calling, and we want to print the title, URL, and the summary while diving into each of those individual results from those 5 results. And I will run this code, and DuckDuckGo search will be called, and it will provide the complete output of this function calling and the for loop. Here, let's look at the result. Result 1. That says title is attention versus self-attention transformer, the published article by the Geeks for Geeks. Here is the link if you want to verify and dive even deeper. Here is a summary. Then we have result 2 in the same way, result 3, result 4, and result 5. Look at this, how powerful and how trustworthy it is. The source, the resource from where the output was created, that's the most exciting part. Here from IBM. Here is from Geeks for Geeks. Here is from somebody in GitHub. Here is from Medium article, Analytics Vidya. Here is from Geeks on Geeks again. So look at this here. This search result looks like to be much more relevant and much more reliable while looking at from where we are getting this output. So this is the power of incorporating web search along with the large language model. So now I'm really excited about the converting search results into the context and providing that context to the large language model and get the final output as our response to the question. Let's dive into converting the search result into the context in the next video. And thank you for watching until the last. I'll see you in the next video. That is part 3 of building the AI agent chatbot with the web search. And if you have not already subscribed to my YouTube channel, please do subscribe and hit that like button if you like this video and share with others. And thank you for watching. I'll see you in the next video. Until then, please enjoy learning.